Hello, it's Mr. Primer here, and in this video we're going to be looking at how to draw ray diagrams in curved mirrors, also known as concave mirrors. So in concave mirrors, all the light that's going into them is going to be reflected inward because of the curve of it. So we're going to start off with this scenario where the object is further than the center of curvature. These points are really important to know. So this point here is called the focal point, and the focal point is the point that any ray that is coming in parallel to this principal axis is going to go through the focal point. So that's a really important point. The center of curvature means that any light that goes through the center of curvature is going to bounce straight back through the center of curvature. So let's start off with this one example. So we are going to start off with getting some light, a light ray here that's going to go parallel to the principal axis. This is the principal axis right here. So it comes in parallel to the principal axis, and because of the nature of concave mirrors, any ray that's parallel to the principal axis is going to go straight through the focal point. So we can get our ruler out and just draw this one straight through the focal point like this. Okay, now we can do another ray of light coming from this object that's going to go from the same point, and it's going to go through the focal point this time. So because it's going straight through the focal point, when it bounces off this concave mirror, it's going to bounce parallel to the principal axis. So parallel to the principal axis. So those are the things that are really important to know for this example. So if you have a ray that is coming in through the focal point, it's going to end up going parallel to this line here, the principal axis. And also, if you have a ray that's coming in parallel to the principal axis, it's going to bounce off and go through the focal point. And then there's one other line that we can do as well, and it's through the center of curvature, because any ray that goes through the center of curvature is going to bounce straight back. So we're going to go here through the center of curvature. We're going to pretend that the mirror continues to go down here. Oops. Okay, and then it's going to come down here and then bounce straight back this way. So we're going to put an arrow going both ways. It's going to come down here, hit the mirror, and then go straight back this way. Okay, so now we have three rays for this diagram, and they all converge right here. So if we call this point A up here, then this is going to be point A down here. And I can draw that in right now. So put that right here. There we go. So here is our object, and here is our image. And to help us understand this better, we can think of the properties that this image has. So the different properties of an image are the size. So size can be either smaller or larger. So in this case, it's smaller than the object. The attitude, which is the physics term if it's upright or inverted, and in this case it's inverted, because you see here that the top of it is actually facing down now. So we will put inverted. Then location. So location is it further from the mirror or closer to the mirror compared to the object? You're always comparing the image to the object. So in this case, it's a lot closer. And lastly, type of image. Type of image is dealing with either real or virtual images. A real image is an image that is in front of the mirror, so the image appears on the same side of the mirror as the object, where a virtual image shows up in ray diagrams on this side of the mirror. So in this case, because it's on this side of the mirror, it is a real image, and that means that the rays of light actually all come together. Okay, so there's our first example. So in this case, the object is kind of far away from the concave mirror, and the image is upside down, and it's smaller and closer to the mirror. So let's look at our next example. So our next example, we're going to move that object up a little bit. So now it's between the center of curvature and the focal point. So let's start off the same way. Let's draw one ray that's parallel to the principal axis. There we go. And because it's parallel to the principal axis, it's going to go right through the focal point. So here we go, through the focal point. And now our next ray can go from this point up here through the focal point. And because it's going through the focal point, it's going to go parallel to the principal axis. Try to make this as parallel as possible here. And then the other one that we can do as well is the center of curvature. So we can draw a line that goes up to the mirror. Pretend the mirror goes all the way up here and hits here, comes straight back through the center of curvature like this. And so you can see all those rays converge right here. So if we call this point A, this point is point A, then the image for point A will be right here. And so we can draw that in now. And so as you noticed, now the image appears larger. So we can go over the SALT acronym again to come up with the properties of this image. So size, it is larger. Attitude, it is still inverted. Location, it is further from the mirror than the object is. And type, is it real or virtual? Well, it's on this side of the mirror still, so it is real. All these rays are actually converging right here. So as you noticed, so far, we started off with this one, where the object was further away from the mirror, and the image was small and close. Now we move that object closer, and now the image is larger and further away. So the closer you move the object to the mirror, the bigger the image gets. Until what happens is you get past the focal point. And when you get past the focal point, something really different happens. So let's see what happens here. So let's start off the same way we always do, drawing a line that's parallel to the principal axis. Because if it's coming in parallel to the principal axis, it's going to go through the focal point. Okay, so there's one ray. Now we usually draw a line that goes from the object to through the focal point, but in this case, this object's in front of the focal point. So what we can do instead is draw a line that is in line with the focal point. And then that will serve the same purpose. So we're going to start down here in line with the focal point. And we don't actually have to draw this part down here. If you want, you can put a little dash to show you what you did. But we're going to start the ray right here. And now it's in line with the focal point. And because it's in line with the focal point, it's going to come off parallel to the principal axis. So there we go, parallel to the principal axis. And there we go. We have two rays here now. So what we can do now is notice that they are diverging from each other. They are going away from each other. So what our brain is going to do is extrapolate that information and find the point of origin. Because our brains are really smart and they know these rays are coming from the same point. And so it figures this point must be back behind the mirror. Just try to line it up here. Okay, there we go. So the top of the point is where these two converge, and it's actually right here. So if this is point A of the object, then this is point A of the image. And you notice that it is actually upright this time. The bottom part of this image is kept along the principal axis because it hits the mirror straight, and it's going to always stay on this line right here. So there we go. So we really just have to worry about the top points of these images, and there we go. So in this case, the properties are different than the previous examples. So for size, it's larger. For attitude, it is upright this time. And for location, it is further. And for type, notice that it's located behind the mirror, and so it is virtual, because the actual rays of light don't converge in a single point. Instead, our brain retraces them and puts the image back here. So that is that example. Okay, now there's a couple other cases with curved concave mirrors that we can go over that might be helpful. And so if the object is at the center of curvature, then what happens is, well, let's find out. We can draw a parallel line that goes parallel to the mirror, or to the principal axis, and through the focal point. So there's one. And then we can draw another one that goes through the focal point and parallel to the principal axis. There we go. And so as you can see, oh, I messed that one up a little bit, but the dot's usually around right here. I just kind of was a little sloppy there. But here we go. So the image is right below it. So it would be like this. Here's point A of the image. Here's point A of the object. And the properties for this one, so if we look at the properties, so the size is the same size. The attitude is inverted. The location is the same as well. And the type is real because it's on this side of the mirror. So it's just right underneath the object. And one other case that's really cool is the case where the object is on the focal point. So if it's on the focal point, what's going to happen is we'll start off the same way we always do, drawing a line parallel to the principal axis through the focal point. There's one line. Now the other line that we can do is in line with the center of curvature, because remember, if it's in line with the center of curvature, then it'll bounce straight back. So it's going to go straight to the mirror and straight back like this. Now, are these rays converging? As you can see, they're clearly not. And if we make some virtual rays for them and see if they converge back behind the mirror to form a virtual image, we will see that they do not do that either. So they are parallel with each other. So on the focal point, no image is formed. And so if you remember, what it looks like when it's right before the focal point is like this. So you'll see the objects here, the image is upside down and larger. And then when you go past the focal point, all of a sudden it's upright. So when it's right at the focal point, the image will actually just be really blurry and non-existent because the rays do not converge together. So that's how you do ray diagrams for concave mirrors, and I hope you are having a great day.